In this chapter, we will learn about relative motion between two bodies, and we begin with a man A who is stationary. Now the man begins to move to the right. Whenever we talk about displacement or motion, it is always relative and it requires another entity for comparison. One entity here is the moving man. So which is the second entity? When the man moves, we say that he moves relative to the ground, which according to us is stationary. Because the ground is stationary, any object fixed to the ground will also be considered as stationary. For example, this tree is stationary. This building is also stationary. This pole P, which is fixed to the ground, is also stationary. Because the man moves relative to the ground, the man can be considered as moving relative to the pole, since the pole is fixed to the ground. Now you can see that as the man moves to his right, his displacement from the pole begins to increase. So for us, it is easier to visualize when we say that the man moves relative to the pole rather than saying relative to the ground, since we now have a fixed point of reference on the ground from which we measure the displacement of the man. The displacement of the man with respect to the pole is expressed as x a with respect to p. In the subscript of x, the a refers to the displacement of the measured entity, which in this case is the man A, and p refers to the pole or the reference point from which we measure the displacement. So we could write x a with respect to p as also x a with respect to g, where g refers to the ground. And we can do this since the pole is fixed to the ground. So x a with respect to p is equivalent to x a with respect to g. Any object that is fixed to the ground can be considered as the ground itself. Whenever our reference point is the ground, we normally write the displacement as just plain xa without the slash. So if we avoid writing the slash g, it is understood that the displacement is with respect to a fixed point on the ground, such as the pole in this case. At the reference point on the pole, imagine that there is a bird who is watching the man. The bird is sitting on the pole, which is stationary. So the bird is also stationary. The displacement of the man with respect to the pole would be the same as the displacement of the man with respect to the bird. The bird is witnessing that the displacement between the man and itself is increasing. So here we are measuring the displacement from the bird's point of view, and the bird is the observer here. So what we do is to attach a frame of reference to the observer or to the bird in this case. Now you see that a frame of reference is attached to the bird. When we talk about displacement of a man, it is really the displacement of a man with respect to the origin or the frame of reference O. So whenever we measure the displacement of a man with respect to some observer, our first step is to fix a frame of reference to the observer, which in this case is the bird. And the displacement is measured from the origin of the frame of reference. And the observer is always attached to that frame of reference. So the man's displacement in this case is how the bird sees it, or from the bird's perspective. Displacement is measured with respect to a reference point. So displacement is always with respect to another entity. In the simplest case, displacement is measured with respect to a reference point that is fixed to the ground. The frame of reference is attached to the observer. The displacement is measured in this frame of reference, which means as seen by the observer.